Hey everyone, and welcome to this explainer. Today, we're going to decode the logic behind SQL filtering. Think of it as building your ultimate data detective's toolkit. You know, if you've ever stared at a massive database and just wondered, how on earth do I find that exact needle in this giant digital haystack? Well, you're in exactly the right place. We're going to start by looking closely at standard operators, see where they kind of fall short, and then discover how to catch those really elusive data patterns using some much more flexible tools.
Okay, so here's our roadmap for today. We'll start with number 1, the art of data filtering. Then 2, standard comparison operators. Moving into 3, stacking conditions with logic. Then we'll hit a roadblock in 4, the exact match problem. Before finally wrapping up with 5, mastering the like statement. Let's jump right in.
Section 1. The art of data filtering. So, the absolutely crucial thing to grasp right off the bat is that the where clause is literally your first line of defense. As the original notes point out, it helps filter or select actual columns, but here's the real kicker. It only returns rows that fulfill a certain condition. Think of it like a strict bouncer at the door of your dataset. It lets you specify exactly which rows of data get to come inside, keeping all that extra noise out.
Section 2. Standard comparison operators.
Now, when you need exact precision, standard comparison operators are going to be your go-to tools, kind of like a surgical scalpel. If we write where first name equals Leslie, well, the database goes looking for exactly that string, no exceptions. But it goes the other way, too. We can also exclude data. So writing where gender does not equal female uses that not equal to operator, which gives us this awesome power of elimination.
And this doesn't just apply to text. We can easily look up numerical thresholds using greater than or less than operators. So, for example, finding anyone with a salary greater than $50,000, or even greater than or equal to $50,000 if we want to hit that exact 50,000 mark. And it works beautifully on dates, too. Just look at this. Birth date greater than 1985-0101. That instantly filters our dataset for anyone born after that specific date.
Section 3. Stacking conditions with logic.
So what happens when we need to combine these clues? Let's start with the AND operator. If you use an AND statement, like say checking for a birth date after 1985, and a male gender, you're making your filter way stricter. Remember this golden rule from the notes. Both conditions must be true for AND statements in order to run. If a row is missing even one of those traits, boom, it gets dropped entirely.
On the flip side, if you swap that to an OR statement, for example, a birth date after 1985 or a male gender, you are casting a much wider net. As the code notes clearly explain, only one of the conditions must be true in order to run. So the database is going to hand back everyone born after 1985 plus all males, completely regardless of when they were born. You can actually even mix this with the not operator, searching for records where they meet the date criteria or not a male gender.
Now, let's see how this builds when we introduce some order of operations into the mix. Sometimes stacking these operators gets, well, a little complicated. Take this combo, where, in parentheses, first name equals Leslie, and age equals 44, close parentheses, or age is greater than 55. Just like in math, the parentheses dictate the order. Step 1. The condition inside the parentheses has to be met first. Step 2. Only after that does it evaluate the OR condition outside the parentheses. This whole setup allows for some seriously nuanced filtering without totally confusing the system.
Section 4. The exact match problem.
All right, so here is exactly where the limitations of those standard comparison operators really show up. If we search for the exact name Jerry using where first name equals Jerry, the source notes confirm this runs as normal. Smooth sailing, right? But what if we only remember the first 3 letters? If we write where first name equals Jer, our precise little scalpel misses completely. Because the string Jer doesn't exactly match Jerry, the notes tell us there's nothing popping. Literally 0 results.
Standard operators demand absolute perfection. So, when we don't have the whole picture, or maybe we're dealing with messy data where names might be spelled weirdly, we need a flexible net rather than a scalpel. In these cases, as the text states, we absolutely require the like statement.
Section 5. Mastering the like statement.
The magic of the like statement relies entirely on 2 very special wildcard characters. Think of them as placeholders for the missing pieces of your data puzzle. The %sign, that means there can be anything after or before the characters you specify. It can represent 0, 1, or even 100 characters. The underscore, though, is different. It means a specific number of characters. A single underscore represents exactly 1 missing character. Let's put that % into action to solve our exact match problem from earlier. By changing our code to where firstname like Jer %, we're basically telling the database, hey, give me anything that starts with Jer, and I don't care what comes after. It effortlessly catches Jerry, Jeremiah, Jerome, the whole shebang. And if we look at like %, we're allowing anything before and after the letters meaning it'll find those letters hidden anywhere inside a name. Pretty cool, right?
Now let's look at the underscore. The underscore is a lot more rigid. In the code like a __ with 2 underscores, those underscores are saying there must be exactly 2 characters after the A. So it would find Amy, but definitely not Adam. You can actually even mix these wildcards together to build highly complex search patterns. Something like a ___ % with 3 underscores means the text absolutely must start with an A, followed by exactly 3 specific characters, and after that, the % says it can have anything else at all.
And here's a pro tip. This flexible net isn't just for text. You can cast your like statement over dates as well. By writing where birthdate like 1989%, you instantly round up anyone born in the entire year of 1989. You completely bypass the need to write out some long, complex greater than and less than logic for the whole year. It's just an elegant, super efficient way to filter data when you know the general pattern but not the exact details.
So, from the rigid, precise scalpels of standard comparison operators all the way to the incredibly flexible wildcard nets of the like statement, your data detective toolkit is officially complete. You understand how the where clause filters out the noise, how and or logic stacks your conditions together, and how wildcards reveal those missing pieces. The only question left is, how are you going to use these powerful queries in your next investigation? What hidden stories will you uncover in your data next? Thanks so much for joining me on this explainer, and hey, happy hunting!